Hello everyone, this is Balu. Welcome to my channel CivilCafe. In this video I am going to discuss about design of pinned connection. Here you can see this is a pin and this is the structural member which is connected to this pin, and this entire structural member is rested on this pin. Thereby this pin is going to undergo bending and also shear is going to occur in this pin, and also we have to design it for bearing also. And also this is also one of the example you can see. These are the some images, you can observe the pin clearly here. And also if you have not yet subscribed my channel, please subscribe my channel and also click on the bell icon so that you never miss the updates. And also why we need pin and where we have to use. That is, pin is used to connect the two structural members. And also wherever you need not to transfer the moment. That means zero movement will be occurring at that pin location. And also there is a free rotation for the structural member, and for that free rotation whatever the friction in between the structural member and also pin is going to be minimized by using any other lubricants and also other things. This is regarding the pinned connection. And you can see these are the some applications of the pinned connection. This is a hinged arch. You can see this is a pin. Wherever the pin is provided in the 3 hinged arch, 2 hinged arch, you have already learnt in the whatever the structural analysis subjects. This is the pin for the free rotation of the structural member. And you can see this is the truss bridge girders, and this is the pin which is provided in between the structural members. And you all know about the trusses. Whatever the truss you can see, those members are designed for only axial force. There is no transfer of bending moment in the structural members in case of trusses. And also whatever the load you are going to apply, the load is going to be applied on the joints only. This you have learnt in the whatever the structural analysis or strength of material subject. That means load is applied at the joints only and load is not applied in between the members. When you are going to apply load in between the members, there is a transfer of bending moment, and bending moment occur in the structural members. That's why the load is applied in the trusses only at the joints. And also these whatever the members are designed for axial forces only. There is no bending moment at all in the truss bridge girders or trusses. Okay, this is regarding the whatever the pinned connection applications. And also if you can see, this is also one of the application, that is diagonal bracing connections. That means whatever the structural members, this is a column and this is the bracing, and this bracing is connected to the column by pins, because this bracing is nothing but the going to resist only axial force. There is no bending moment resisting capacity for the bracing. The main purpose of the bracing is to transfer axial forces only. That's why this bracing is connected to the columns by the pins. Here you can see it is not shown clearly, but basically these bracings are for axial force only. They are connected by pins. And this is the one of the practical image. You can observe clearly this is a pin and this is a structural member which is connected to the pin, and thereby base plate, and total entire load is transferred to the ground. And coming to the whatever the design provisions, BS 5950 Part 1 given the design standard for pinned connections. And remember, IS standards didn't give any provisions for the design of pins. But whatever the basics formulas, that is, for example, bending moment capacity, design bending moment is nothing but beta B into ZP into Fi by gamma MO. You can use this formula for checking of the pin also. Just you have to substitute the plastic section modulus and also yield strength of the pin, and you can check the bending moment capacity of the pin. Here you can see this is the whatever the provisions which is given. First thing is, that is, rotation is required and pin is not intended to be removed. You want to rotate that structural member through the pin, and also that pin is permanent and you do not need to remove that pin. It is permanently installed. In that case, this is the formulas, that is for shear capacity, bearing capacity and also bending capacity. Here coming to the A is nothing but cross sectional area, that is pi by 4 into d square. For example, this is a pin and this is the diameter of the pin, and this is the cross sectional area, that is pi by 4 d square. Next, coming to the FYP, that is yield strength of the pin. Next, coming to the bearing, you can see that is Fy. You have to take the minimum of the yield strength of the pin and the structural member. Next, D is the diameter and T is the thickness. That means, for example, this is the pin and this plate is connected to this pin, and whatever the thickness, that is thickness of the plate which is in contact to that pin, this is the contact of this pin. That T is you have to consider in case of this bearing. Next, coming to the bending, that is yield strength of the pin, that is FYP. Next, Z is the section modulus. You all know section modulus, that is I by Y. Next, I is nothing but centroidal moment of inertia, that is pi d power 4 by 64, and Y is nothing but d by 2. You are going to get pi d cube by 32. This is regarding the section modulus of the pin. Next, second case, rotation is required and pin is intended to be removed. That means whatever the structural member which is connected to the pin, that rotation is required, and also whatever the pin, it is just temporarily installed and you want to remove whenever it is required. In that case, this is the formulas you have to use, and whenever the pin is you have to install permanently, then obviously whatever the strength of the pin should be high. That's why you can see whatever the formulas, that is higher value you can get the in case of whatever the pin is installed for permanent purpose. Next, coming to the how you have to find the bending moment in the pin and also shear force in the pin, that I am going to discuss now. Here you can see this is a structural member which is connected to the pin and also thereby two plates surrounded by the pin. Now whatever the load coming is going to be act against this pin. For example, this is the load P which is going to act against the pin, and you can see this image. This is a member, that whatever the, for example, this is a structural member. That structural member is nothing but given here, and whatever the load coming onto it, we can consider that is load P. Next, coming to the two plates which are resisting in the opposite direction, and those two plates are given here. You can see clearly, those are with light colors. Next, you can see this is the pin which is in the orange color. Next, you can consider this pin as simply supported beam. Now, if you consider this as simply supported beam, this is the load P which is acting, and in the opposite direction, you can consider these two reactions, that is P by 2 and P by 2. Just observe clearly, whatever the structural member which is going to be connected to the pin as acting as a point load, and next whatever the plates which are in the opposite direction, those are acting as a supports. So this is the philosophy regarding the design of the pin, and you can consider whatever the area in which the structural member is going to be connected, you can consider it as UDL also. But for safer purpose, whenever we consider it as point load, we are going for higher safety side. So it is better to consider it as point load only. Now you all know about whatever the simply supported beam. What is the maximum bending moment? That is nothing but P into L by 4. Next, here whatever the load P which is acting exactly onto the pin, so we have to consider the shear force which is acting on the pin, that is P only. Next, coming to the bearing, here you can see this pin is connected to the structural member and also two plates. So whatever the cross section in which it is going to be contact with the pin, you have to check for that. For example, this structural member is there. Here, whatever the pin is going to be contacting with the two plates, and this is the cross section you can see. And also structural member is also in contact with the pin. And whenever you are going to check for the bearing, here there is diameter into thickness is a cross section in area in which it is going to be resisted through the bearing. So for that case, you have to consider these two cases. Here one is two plates are there which is connected to the pin, and the load is P by 2. And coming to the whatever the bearing check, you have to consider in this case this cross section, that is diameter of the pin and also thickness of this plate in one case. Next thing, whatever the diameter of the pin and also thickness of this second plate, that is T2. So in first case, whatever in T1 case, you have to check for the P by 2 load. And coming to the second case, that is second plate, that is structural member, which is having thickness of T2. In that case, you have to check for the maximum load, that is P. In this way, you have to check for the bearing. Thank you for watching this video.